Welcome to the 6th video of the Beginning Artificial Intelligence series. In this video, we are going to go over the basics of audio manipulation, which will be important for projects such as sound recognition and speech recognition. This is the audio module in my utils package, which I plan to fully release at the end of the series. So let's start by looking at a couple useful features by opening command prompt, typing Python, and importing the module. We can then record an audio. Hello. This will record for 1 second with a sample rate of 16,000. That's actually relatively low. Nice audio will be like 41,000. The audio is stored in X, the sample rate in R, and then the A type is the audio type, which doesn't really matter. You don't need to worry about it much. You could load from a file with the load function. You can look down here how to use it. You put the file name, the rate if you want to change the rate when you load it, and then assert mono pretty much means that if it's multiple channels, it's going to throw an error if it's true. If you don't, it will just automatically change it. So if you put false there, it'll just automatically change it to one channel, because this module only works with one channel. Okay, so now what we can do is we can actually play the audio with this function right here, play audio and the sample rate. Hello. We can calculate the duration, which is 1 second. We record it for 1 second. We can actually get the size real quick just like this because it's a NumPy array. And you can actually get the D type. It's just a float 64. So it's a normal NumPy ND array. And with that, we can actually set the length by knowing this. We can cut it in half by putting 8,000. Hello. So it cut off part of that hello right there. We can also set the duration with this function, but this time it's in seconds, so it's going to increase the length. And we can change the mode. Both these functions, set duration and length, you can change the mode. So if I put L, it's going to be left, and if we look at the code real quick, we can see that the left mode, or the L is for left mode, the R is for right mode, and B is for both. And what that pretty much means, it will either, to shorten it, it will just remove from the left or right or both equally, or we can use right, or it will add to the left, right, or both. And when you do both, let's say back to the example of 8,000, it's going to cut 4,000 on each side. It doesn't cut 8,000 on each side. It cuts it half of it on both sides. All right, so now we can press enter. Hello. So you can see how it padded an extra second at the beginning by putting left. We can now call a function called for each frame, and I'm going to set it to a variable. I'll call it x2 and r2. It returns an it returns not really an audio, but it will return a one-dimensional ND array, and then it will return the sample rate of that. Okay, so that's again audio sample rate. This is the frame duration. You can make it. You want to make it like less than the length, the duration of x2 or x. I mean, but you can make it whatever you want. If you make it too small, of course, it won't work either, but it's fine. You can just mess with that. And then the calc RMS will calculate the root mean squared, which is pretty much going to give you the power of each 0.1 duration frame. So now we can actually go plot x2, because if we were to run it, it would sound weird or not even work. And so we can see how we really made it like that. But if we look at the real audio real quick, it's a lot more bumpier, a lot more information. So you can see that. Alright. We can also calculate the spectrogram. The spectrogram does not overlap. I've done some tests, and I don't think you need an overlapping spectrogram to get the neural networks and other machine learning types of things to work with overlap. So I just don't have it. It uses the for each frame, so it keeps it all simple. And we can see how the spectro, that's just that's a 2D array, and then spectro rate just gives you a rate. That's only really useful if we were to do let me copy that again. If we were to convert the spectrogram to an audio again, it's important to have this right here, but otherwise we don't really need it. Hello. So you can see how I could just play it back. So we converted it to a spectrogram, and we got it back to an audio, which can be useful if you want to teach the computer with a neural network to output a spectrogram, and then you can convert it to audio, and then now the neural network can pretty much speak. We can also view the spectrogram. So this is 2D. 3D would be a little better to view it, but you can see each line's a different frequency, and this is the amplitude of that frequency. I think it's the amplitude. Now we can also change the pitch with the shift pitch function. This will shift it 100, so it's going to be higher. Hello. And if we were to shift it down, hello, it's deeper. And these are a little exaggerations by having such high numbers. We can do 10. Hello. So you can kind of hear it in there. We can also set the power. Like that. Hello. You can see now it's not as loud. We can multiply it. Now it's going to be 2 times as loud. Hello. So that can be useful, especially if you want to set the exact power. So we can do 0.01. Hello. And so that was less loud. And we could actually, real quick, go look what is the power of this audio. The root mean squared of it. We can just give it x, and I think that's it. Yeah. So it's 0.03. So us giving it just 0.01, we just pretty much made it less loud. We can also adjust the speed. With this, it's going to be 2 times faster.
Hello.
And if we want it half as fast.
Hello.
And we can also set the speed with seconds in mind. So if we want the audio to take 2 seconds.
Hello.
Or if we want the audio just to take about 0.2, you can see. So that can be useful for like normalizing a data set if you want to. Of course, it will mess up the frequencies a little bit, but if you wanted to, you could use that. We can also adjust the volume with this function, a little different than power. This will pretty much just multiply x by 2 with clipping it, so to make sure that you don't get values over the max, which is 1. And the lowest is a -1 if I did not mention that yet. Hello. So now it's 2 times louder. We can put 0.5. Hello. It's not. Okay. So those are just some basic functions you can use with this module. There's a couple others. We can see you can blend. You just give it 2 audios. The weight, it's pretty similar to the image one if you watched that video. And then that's just the plot function. If you give it a second or 2 seconds, it will just stay open and then automatically close. And then you can convert audio to decibels, convert power to decibels, which this pretty much just does that, but it also converts it to power first. And then we can do amplitude to decibels. We can trim, which is useful. This will trim anywhere that it's ambient noise, it will trim. And then you can trim the sides. You can split it. These functions are all made by me, so that the algorithms aren't the best. You can find gaps. These algorithms are really good for voice. They're pretty accurate. So if you want to actually split on like words and stuff, like on a sentence, these are really useful to use because these are specifically for voice. This is just for ambient noise, so it's not the best because of that. And we can see VAD split. And this is just a test if you wanted to run that. I haven't actually ran that, so we can run that right now by going out and just typing Python audio. Hello. Oh, hello. Oh, hello. This is just going to do a bunch of stuff. So this pretty much does what everything I said, but it just does it to make sure it all works. That's a lot. Oh, hello. And so we brought it back like I showed earlier.
Oh.
Hello. And that's just taking the average. Oh, hello. Okay. Well, I'm not going to let it all go. Thank you for watching. In the next video, we're going to look at pure TensorFlow and probably not anything to do with Keras, just pure TensorFlow. And then in the video after that, we'll get into more Keras and TensorFlow, probably with my neural network module, which just makes it a little easier to have data sets, especially your own data sets, and view them and stuff like that.